Good morning to all. We are discussing the finite automata with output. So there are two types of automata. They produces the output. They are called as the Moore machine, and another one is called as the Mealy machine. So far we have discussed about the both the machines, that is Moore machine and the Mealy machine. So the automata like your NFA or DFA, or it may be NFA with epsilon moves or NFA without epsilon moves. So these automata, these finite automata, they are the language acceptor, or they are also called as the language recognizers. And these automata, they are not going to give any kind of output. They are not able to produce any kind of output. We are just getting the answer whether a given input string, whether a given input string is accepted by that automata or not, means yes or no. In this particular format, we are getting the answers from the your DFA, that is deterministic, as well as non-deterministic finite automata. They are not going to produce any kind of output for the given input string. But in case of finite automata with output, means this automata is able to produce the output for the given input string. That is nothing but your Moore machine and the Mealy machine. So we have seen the definition of Moore machine, what exactly is the definition, and how the Moore machine works. So the output is associated with the state only. In case of Moore machine, the output is associated with the state. It does not depend on the input as well as the transition. So Q0 is having some output that is 0 or 1. Q1 associated with some output either 1 or 0. Then Q2 state having some output associated in that particular example. So we have to find out. So suppose if the input string is given, so we have seen already how the output string is being generated in case of Moore machine. So in case of Mealy machine, we can have this output which is associated with the input as well as the transition from Q0 to Q1 or from Q1 to Q2. Right? Means there are the two parameters in case of Mealy machine that is affecting your output. That is nothing but the transition from the state, one state to the next state, and the input symbol. So we can say the output is totally dependent upon the input as well as the state transition in case of Mealy machine. So in the previous lecture, we have discussed about the conversion. So, and these two machines, they do not contain any final state. That already we have discussed that there is no final state in case of Mealy as well as the Moore machine, right? And from the equivalence point of view, both machines are equivalent. You input any input string, so you will get the same output. You will get the same output by executing by this particular both the machines, right? So Moore machine as well as the Mealy machine, they gives you the, they produces the same output for the given input string. So conversion of conversion of Moore machine to the Mealy machine already we have discussed. And now in the today's session, we are going to discuss the second one, that is nothing but the conversion of Mealy machine to the Moore machine. So let us see the how to convert Mealy to Moore machine, right? So let us start with this conversion of Mealy machine to the Moore machine. See here, so in Moore machine, the output is associated with every state, and in Mealy machine, the output is given along the edges with the input symbol. Means you have this 1 oblique 1 slash 0. So where 1 is nothing but your input, and this is nothing but your output. Or you can have 0 or 0. So these both 0, though they are 0, but they have different significance. So first character represents your input, whereas the second character represents your output, and they are given on the transition. Say for example, Q1 goes to Q2, you have 0, 0. That is nothing but Q1 on input 0. See here how to read this Mealy machine. Q1 on input 0 goes to state Q2 and produces output is equal to 0. Right? It may be, say for example, 1 oblique 0. So Q1 on input 1, given input 1 goes to state Q2 and produces output 0. Right? So this is the way for in case of your Mealy machine. So Mealy, we can say that the output depends on your input as well as the transition from one state to the next state. But in case of your Moore machine, a very simple one, in case of your Moore machine, you have Q0 slash 0. So this is written inside that particular state. Q1 oblique 1, for example, Q1 oblique 1. So this Q1 is the state and slash 1 is nothing but the output. Getting this point? So when this state is being executed, this particular state Q0 or Q1, what it may be, when it is executed, this output 1 or 0, it is printed, right? So this is the case. So to convert the Moore machine into Mealy machine, right? Machine state output symbols are distributed to input symbol path. But while converting Mealy machine, now what we have to convert? We have to convert Mealy machine, means this particular machine, to the Moore machine. We will create a separate state for every new input symbol. So which is the input symbol? Your sorry, new output symbol. And output symbol is nothing but your this one is nothing but your capital delta is nothing but your output symbol. So you have to create new state. You have to create separate state for every new output symbol, and accordingly, and for this particular thing, what we have to do here, we are accordingly incoming and outgoing images are distributed, means for each input. So first step, you have to generate, or you have to find out the separate state for every output symbol. So your state, so q consists of your q into output symbol, means this state is now comprised of your q into number of output symbols. So current state into number of output symbol. This gives you the new state, and for every generated new state, for every new state, you have to take the input. So on each input, whatever may be input symbol you have to generate the transitions. You have to generate the delta transitions, and you have to generate the lambda dash transitions. So see here, Mealy machine. So Mealy machine is described by m dash equal to q sigma capital delta small delta lambda q0, where delta transition is written as q into sigma, that gives you q, and whereas the lambda is equal to q into sigma gives you the capital delta is nothing but the output function, and this is nothing but your transition function. But in case of your Moore machine, you have m dash equal to q dash sigma delta capital delta small delta dash lambda dash and q0. So how many parameters are changing here? So your states are being changed here. In the given Mealy machine, it is a q, but we have to form the new set of states. See carefully in the resultant, when you have to find out the Moore machine from the Mealy machine, first you have to generate the q dash. This thing will be the newly generated here. This thing q dash will be newly generated, whereas this symbol sigma remains same. There will be no change in the inputs, right? And capital delta, this is also remaining the same here. Output symbols, they are also remain same here. Now delta, see here, now here in Mealy machine you have delta, but for the resultant Moore machine you have to find out the delta dash. You have to find out this delta dash. And in the given Mealy machine you have the lambda, that is nothing but the output function. So this output function, it is now being converted into the resultant lambda dash, means in Moore machine these three parameters are, you have to find out, or you have to identify these three new parameters as compared to the given Mealy machine. Or reversely, we can say that from the given Mealy machine, we have to find out these three parameters where q0 remains same. So we have this input set remains same, output set remains same, and q0 start state remains same in both the machines in case of Moore and the Mealy machine. But which parameters are being changed here? So parameter changing, that is q. You have to find out the new set of state. You have to find out the delta dash transitions, and you have to find out the lambda dash output function. So how it is to be find out? So see here. So we will calculate delta dash and lambda dash as, first delta dash is equal to, see here, this is the formula given to find out the delta dash transition. This you can calculate by this delta dash q comma b. So q is nothing but the state. Now b is nothing but your output. See here, b is nothing but your output, and a is nothing but your input symbol. So whatever maybe the outputs are given here, so you have to take. So as per this particular sentence, or as per this separate state for every new output symbol, so that's why qb. So qb is nothing but the state, where b is the output and a is nothing but the input. That is equal to delta into square bracket into round bracket q comma a, means this q comma a comma lambda q comma a. This is the formula to find out the delta dash transitions. See here, right? So see once again, delta dash q comma b comma a. So this b is nothing but your output. This a is nothing but your input symbol. So how many output symbols are there? There may be output symbols like a and b. So you have to generate, see carefully, listen carefully. You have to generate the new state for each and every output symbol. First step, you have to generate the separate state for every new output symbol. There may be output symbol A, B, or there may be output symbol 0 1, any output symbol as per the given problem. So and states are, you have q0, q1, q2, any number of states are there. So you have to generate the state like this, q0 comma say for example a. This becomes your one new state in the resultant Moore machine. This become your new state in the resultant Moore machine. And once this resultant new state you have generated, now the transition and output, say sorry, input, maybe suppose input, these are the output symbol here, this is nothing but your capital delta, and you say for example your sigma equal to 0 comma 1, input symbols are 0 comma 1. So q0a on 0 and q0a on 1. Are you getting this point or not? So q0a, this becomes the new state, q0a, this becomes the new state. So transition of this new state on input 0 and transition of q0a on input 1, that we have to find out here. This is the second step. So first step, number of states into number of output symbol. That means that what we are finding out here, we are getting this q into capital delta. Q into capital delta, this is nothing but gives us our resultant q dash. Getting this point? Once you find out the resultant q dash, then you have to find out the transitions for this q dash. This is nothing but your q dash. So this is q, then output and input. So on every input symbol, you have to find out the transition. Then how to find out the transition? Delta dash. How to find out this delta dash? It is given in the equation, equal to delta square bracket into round bracket q comma a comma lambda q comma a, means this is the transition and this is nothing but your output function. So you have to find out the output for q comma a, where q is the state and a is the input. So this is input, a is input here and a is input here, and this q is nothing but your state. So this is the first step to find out the delta. And the next step to find out the lambda dash. So lambda dash is find out with this equation, lambda dash qb. So this is again, lambda dash is nothing but state, b is nothing but your output. This is b is output. So you are getting whatever it may be the output as per the given table or the given transition diagram. So with this, we are finding out the lambda dash transitions. Getting this point? So we'll see examples that will become more clear. Okay, so just remember this point, how to convert. So conversion of Mealy machine to Moore machine, we have to follow these number of steps. First, we have to find out the new output, find out the new state for every output symbol. Then once the new states are being found out, this is the first step. Then second step is we have to find out the delta dash transition. And third step, we have to find out the lambda dash, that is nothing but the output for that particular state. So lambda dash means what? This is nothing but the output for state q. So we have to find out because in Moore machine, remember always, the output is associated with the state only. So for example, q0, what is the output? It may be a, b, or it may be 0 comma 1 as per the problem, right? That we have to identify, that we have to find out, right? So let us see with example. See here, convert the following Mealy machine into equivalent Moore machine. The problem is given like this. The transition diagram of the Mealy machine is given here. So q0 on 0 goes to q0, output is 0, that is the self transition. q0 on input 1 goes to state q1, output is 1. q1 on input 0 and on input 1, both inputs are there, but both are self transition. But in case of 0 input, output it produces 1, and in case of 1 input, output is 0. So see here, first draw the transition table. For the simplicity, for the understanding purpose, let us draw the transition table for the given Mealy machine. So the transition table, as you know, that we have to draw for input 0. So there are two columns pertaining to input 0. So see here, this is the thing. So state and lambda, that is nothing but q0 on input 0 goes to q1 and produces output 0. q0 on input 1 goes to q0 and produces output equal to 1. So this is first column for input 0, and this is the second column for input. This is second entity and this is the first entity. Same case for q1. q1 on input 0 goes to state q1, produces output 1, that is means this one, and q1 on input 1 goes to q1 itself and produces output 0. That means this is that particular transition, right? So this thing is over. Now second is q dash. What we have to find out here? We have to find out the q dash, that is the resultant set of state for the resultant Moore machine. So finite set of state where each state is a pair that is obtained from, see here, obtained from q into capital delta, that is nothing but your state into output. That is nothing but your state into output. So how many states are there? So there are state Q0 and Q1. What is, and how many outputs are there? There are output 0 and 1. So I will form the state like, so I will form the new state. I will form the new state like this: Q dash equal to, write down here, Q dash equal to into curly bracket. So this becomes my first state, Q0 comma 0. So take this one, Q0 comma 0, then Q0 comma 1. So this is the one, Q0 comma 1, then Q1 comma 0. So Q1 comma 0 is the third state, and Q1 comma 1. So Q1 comma 1, this is the nothing but the fourth state. So straight away you can have two states and you can have two input. That means how many new states will be there? Definitely there will be four new states. There will be four new states. So this 0 is the output. Remember this one. This one is output. This is the output. Output. This output and output. It is not input. So see here why this confusion is there, because there are output symbols are also 0 and 1 and inputs are also 0 and 1. But do not get confused. Do not get confused between input and output symbol, right? So see here. Next step is, so once you find out these are the Q dash state, means these are the states which belongs to resultant Moore machine, right? The machine which we are finding out or machine which we are drawing, these will be the states, four states, Q dash. Next, the transition delta dash. Next step, third step is to find out the delta dash transition and output function, that is nothing but the lambda dash, can be obtained by the formula we have discussed just now. Delta dash, it is to be find out with this Q comma B, that is nothing but this one, Q0, in this case Q0 comma 0 comma, what is the input symbol? Input symbols are 0 and 1. So input symbol will first take 0 and the bracket complete here. So this bracket complete, this is the delta dash, that is equal to, getting this point. And second delta dash, I can have delta dash into round bracket into square bracket. The state is Q0 comma 0, and what is the input? Next input is 1. So I can have 1 here and I can have the formula. So in this way, I have to find out. So how many transitions will be there? Can you tell me how many transitions will be there? Because how many states are there? Now the new states are 4, and input symbols are, how many input symbols are? 2 input symbols. So multiplied by 2, that means you will have 8 new transitions, delta dash transitions. Getting this point or not? Key 4 new states we have identified for the Moore machine, and this 4 new state like this with this formula, when we have to find out the delta dash transitions on input, that is 0 1. 2 input symbols are there, 0 and 1. So Q0 0, one state on input 0, and Q0 0 on input 1, means like this way two transitions for the one state and 2 transition for another. Sorry, there are 2 transition for a single state we have to find out. So 4 state multiplied by 2 input, that is equal to 8 total transitions will be there. And finally, the lambda dash is nothing but the output function. We have to write down with this Q. Sorry, that is nothing but Q comma B equal to B. So Q0 comma 0, that is equal to, so this B as it is we are writing here, so that is equal to 0, lambda dash. Getting this one, so 0. So value for Q0 is nothing but 0 here. So in this way, these are the steps we have to find it out. So let us go to the next step here. So transitions, delta dash transitions for the different states of Q dash on different input symbols are obtained as the Q0, delta dash Q0 on 0 equal to 0. So see here, so Q0 on 0, Q0 0, this is the state, and this is your state, and this is your input symbol. So the formula says that you have to write down in a square bracket delta Q0 comma 0 comma lambda Q0 comma 0, that is equal to. So find out value of delta Q0 comma 0. Delta Q0 comma 0 is the value of Q. It is nothing but your Q0, and lambda Q0 comma 0 is nothing but 0. So that's why answer is written in the square bracket Q0 comma 0. So always remember that while writing answer for the Moore machine, always write in a square bracket. Always write in a square bracket, right? So and finally, then delta lambda dash Q0 on 0, that is equal to 0 from the transition table. Lambda dash Q0 on 0, that is equal to 0. So this you have to write like this. Say for example, that is nothing but your Q0 comma 0. And finally, this is nothing but lambda dash Q0 comma 0, that is equal to 0. So these 2 parameters or these 2 transitions you have find it out. So in the same manner, we have to find out remaining 7 transitions. So that is nothing but, see here, How they are written here? Delta dash q00 on input 1 now. So you are changing input here. You are changing the input. This input is initially 0. Now we are changing it to 1. So here delta q01. So you are not taking this symbol 0 here, but you are taking this particular. You have to use this one. So q0 on 1 and lambda also q0 on 1. So delta q01. So delta q01 value is q1 and lambda q01 value of lambda q01 is nothing but 1. That's why the answer is q1. Answer is written in a red color, so it is marked. It is written as a q1 in a square bracket and lambda dash q0 on 0, that is equal to 0. So these two transitions are complete. Now see the next transitions, delta dash q0 comma 1. See here, now q0 comma 1. Now you have changed your output. This is your output. This is your output column. So this is your output. This is the output, and this one is your input. See here, this is input. This is input, and this is your input, right? So what you have your third state. Your third state is q0 on 1. q01. This is nothing but your third state. And now this third state you have to find out on each input, that is 0, and the next is 1. And you have to take q0 on 0, that is nothing but the delta transition q0 on 0 and the lambda transition q0 on 0. So the answer for q0 on 0 is equal to q0 and the lambda q0 on 0, that is equal to 0 itself. So this is the third answer we got here. And lambda dash q0 on 1, q0 on 1, this state, this is the third state, that is the q01, that is equal to 1 here from the transition. And all these value are given in the transition table or in the transition diagram. From transition diagram or the transition table, we have to write all these values, right? What will be the next transition? So next transition will be q0 on 1, and now output input is being changed here. Instead of 0, now you are writing here 1. So this is nothing but the delta dash equal to, getting this point. So see here, delta dash q01 on 1, that is equal to delta q01 lambda q01. So value of delta q01 is equal to q1 and value of lambda q01 is equal to 1. So this is the fourth transition, right? This is the fourth transition. And now lambda dash q01, lambda dash q01, we have to find out lambda dash q01, that is for fourth state, that is equal to 1 here, that is equal to 1 here. Getting this point? So in this way we have completed the 4 transitions. In this way we have completed the 4 transitions. Now you can see here q00 on 0, q00 on 1. This is the state number 1. This is the state number 2. State number this is the state number 1. Sorry, this is the state 1. State 1 on input 0, input 1. This is the state number 2. This is the state number 2. q01, q01. This is one state. Combiningly, this is called as the one state. That's why it is written in the square bracket. So this one state on input 0. This one state on input 1. So these are the 2 states. These are the 2 states. Still 2 states are remaining, because how many states are there? There are total 4 states. Now which are the 2 states are remaining? So that is q1 on 0, this is the state, and q1 on 1, this is the third, and this is the fourth state. So q1 on 0 comma 1 we have to find out, and q1 on 1 on 0 comma 1, that is nothing but remaining 4 transitions we have to write here. So see how they are written here. q0 on 1, q01 state number 3 on 0 input, right? q01, so same you have to write here. You have to take this 0, you have to take this input always. You have to not take this output. You have to take the input q00 and lambda, sorry, q10 and lambda q10. So answer for q10 is nothing but your q1, and answer for lambda q10 is equal to 1. This is the 5th transition, and finally the lambda dash q10, that is equal to 1 from the transition table itself, right? And the next transition is nothing but delta dash q10, the state, third state on input 0, on input 0. So here what we are taking here, now we are taking this 1. So q1 on 1, so delta q1 on 1 and lambda q1 on 1. So delta q1 on 1 is nothing but your q1, and lambda q1 on 1 is equal to 0, right? So these two values are written. So this is the new state, this is the new transition we have find out here. Lambda dash q10, that is nothing but the same. So see here, you can observe these 2 entities are same, whereas these 2 entities are same, and this q1 on 0, these 2, because we are getting the same answer here, or this is the same, because lambda dash q10 answer will be the same for this state q1, for this state Q1 0. This is the state Q01. This is the state Q00. This is the number one state. This is the number two state, and this is the state number three. Getting this point. Now the remaining, the last state is Q11. This is the last state. This is the state number 4. Q11. This is the state number 4. We have to take the input 0. So Q1 on 0. So Q1 on 0 goes here. So Q1 on 0 answer is nothing but the Q1, and lambda Q1 0 answer is 1. Getting this point. So this way we have find out the transition for this, and finally the lambda dash, that is the output function Q1 on 1, Q1 on 1 equal to 0, right? And the one still transition is remaining, that is Q1 on 1 and input 1, and input is equal to 1. So state number 4, this is the state number 4, and input is now 1. So Q1 on 1 we have to take here delta Q1 on 1. So the answer for this Q1 on 1 is nothing but Q1, and lambda Q1 on 1, answer for this nothing but 0. So this is the last transition. And finally the lambda dash Q1 on 0, that is equal to 0. And these two transitions are same, these two inputs are same. This is the state number 4. Getting this point? So in this way, this is the way we have to solve. We have to find out all the delta dash transition. These delta dash transitions we have find it out. So total delta dash transition for a newly generated state, and total lambda dash values we have find it out here. All these lambda dash values. Getting this point? Now the next step is to write down the transition table. See how to write down the transition table. So in Moore machine, how many output column? There is only single output column, right? So see here, transition table for the Moore machine can be written as 0, 1 is the input, and how many states are there? Total states are 4, Q00. So now in the Moore machine, there are the states Q0, 0, Q0, 1, Q1, 0, and Q1, 1, right? And the transitions which we have just find it out, we write down Q00 on 0 goes to Q00, right? This is the answer. And output lambda for this Q00 state is 0, right? Q00 on input 1, the state is Q11. The state is Q11, and output remains the same. Means these are the first two transitions we have written here. The next two transitions, Q01 on 0 goes to Q00, Q01 on 1 goes to Q11. That is the next state. This is the next state, and the output for Q01 is equal to 1. This is the two transitions. Next two transition. The next two transitions for Q00, two transitions, and the next two transitions for Q11. So total number of transitions are 8 transitions. 8 number of transitions are there, and these are the total 4 output symbols. That is 0 associated with this particular state. 1 output is associated with this Q01 state. Now Q01 is the 1 state. So see here, all the states are written in the square bracket because Q0, 1 is the 1 state. It is comprised of 1 state, single state, and they are not the 2 states. That's why written in a square bracket. So from this transition table, we have to draw the resultant transition diagram for the Moore machine. So equivalent Moore machine can be drawn as with this way. Okay, so Q00, first take the first state here. Q00, take the first step. This is the first state. The output output is 0, so that's why give a mark /0. It is written here, right? Then on 0 transition is nothing but the self loop. That's why it is marked as a self loop. Now on 1 it goes to Q11. On 1 transition it goes to Q11. So second circle drawn here, the state drawn here Q1, 1, and the output associated with 1 Q11. So here is a Q11, and output associated with this state is 1. That's why /1 it is written here. Now the next state, take the next state Q0, 1. Q0, 1 is drawn here, and output is associated with this 1. So /1 is written here in the state. Now on 0 it goes to Q00. So on 0 it goes to Q00. That's why this transition on 0, and on 1 goes to Q11. On 1 goes to Q11. So this is the second transition, right? Now next state is Q10. So state is written here Q1, 0 into square. They are in the square bracket /0. Output associated is 0. That's why /0 is written here, right? Then Q1 on 0 goes to Q11. On goes to 0 goes to Q11. That's why it is on 0 input goes to this particular state, right? That's why it is written. And on 1 goes to Q10, and 1 goes to Q10 means it is the self transition. This is the self transition, right? And finally the Q1, the two transitions on 0, the self transition, and on 1 it goes to Q1 0. So this is the transition for this. So all 8 transitions are marked here, total 8 transitions with the 4 states are marked. So these are the new state, these are the 4 new states here, 4 new states for the resultant Moore machine, resultant Moore machines we have generated, and this we have found out with the equation Q into, so Q number of states, existing states into output symbol, right? And once you have found it out, so you have to take on each input symbol and each input symbols to find out the delta dash and lambda dash. So this is the entire method. Method in shortcut, I have explained here. So first we have to find out the new state, Q dash. So Q dash is found out with the help of output function, output symbols, and current state, that is nothing but Q0, Q1, and output are 0, 1. So we have find it out the states like this: Q0, 0, Q0, 1, Q1, 0, and Q1, 1. These are the 4 states, and input symbols are again 0, 1. So there are total number of 8 delta dash transitions, and total there are 8 lambda dash functions, output functions we have written. And with this, we have to write on the transition table. And once the transition tables for this state, Q dash, for this state Q dash. And once the transition table we have written, then it is easy to draw the equivalent transition diagram for the equivalent Moore machine. Getting this point? Okay. So let us go to the another example. It is very simple. There is no any difficult part is involved here. Only the thing is that you have to carefully, you have to follow each and every step. For that, you have to practice it. You have to make a more and more practice of this conversion from Mealy to Moore and Moore to Mealy machine. And one thing is that do not get confused, because most of the time the problem occurs. The student, they get confused between the conversion of Moore machine and Mealy machine to the Moore machine. But if you are confident, if you practice it, so there will be no any problem. It will become very simple. So the next Mealy machine is given Q0, Q1, very simple. The transition table is also very simple. Output input 0, input 1, Q0, Q1. Only 2 states are there and 2 inputs are there. That is, input is 0, 1. Now here outputs here. So this from this example, this it will become more clear to you. Now outputs are different. In earlier, input is 0, 1, and output is also 0, 1. So that's why a little bit confusion was there. But here outputs output is AB. So I can have capital delta is equal to capital A comma B, and I can have sigma equal to 0 comma 1, that is input alphabet, and I can have Q is equal to Q0 comma Q1. So I can have this Q dash equal to Q into Q into capital delta. That means I can have Q0A is the one state, then Q0B is the another state, Q1A is the third state, and Q1B is my fourth state. So these are the 4 states. Now, once the 4 states I have identified, so all the 4 states on input is nothing but now inputs are 0 and 1. So I have to find out the delta transitions on into bracket, into square bracket, Q0 on A, on input 0, it is the delta dash Q0 on A, on input 1. So it's very simple, and it is very simple that I have to find it out. And same for this second state, third state, and fourth state. So again, there will be 8 transitions. Delta dash we have to find out, and lambda dash 8 values we have to find it out. Getting this point. So let us start solving it. So Q dash is nothing but the finite set of states where each state is a pair obtained from Q into capital delta. That is nothing but your state and output symbol. So Q dash is equal to into square bracket. Always write state in the square bracket while converting, while going towards the Moore machine. So Q0 comma capital A, Q0 comma capital B, Q1 comma capital A, and Q1 comma capital B. These are the 4 newly generated state. The next step, is the transition delta dash function and output function obtained with the help of this particular equation. That is delta dash Q comma B comma A, that is equal to delta into bracket Q comma A comma lambda Q comma A. That we have to find out here. So see here, so and the lambda dash is nothing but your Q comma B, that is equal to B. So let us start finding out the delta dash transition. So transitions for different states of Q dash on different input symbols are obtained as delta dash Q0 comma capital A comma 0. So this is nothing but your state number 1. So this is nothing but your state number 1, and the input symbol is 0. This is your input symbol, and this is nothing but your state number 1. Q01 is now it is the state 1. So how to solve this? Q0 on 0. So delta Q00 0 and lambda also Q00. So value of delta Q00, this is there is a comma is here. So the value of delta Q00 is nothing but Q0. And value of lambda Q00, value of input. Lambda means you're finding out the input. So lambda Q00 is nothing but the A, capital A. So this is the answer for this transition. This is the first step, right? And next is nothing but lambda dash. That is nothing but we have to find out the output for this particular state Q0 comma A. And the output for Q0 comma is equal to A. So this A you have to just write down here. That is nothing but A. Clear? So next is delta dash Q0 comma A. Take the same state again, the state number 1 again, and now change the input symbol. So input initially it is 0. Now it is changed to 1. Input symbol is now 1. So delta Q0 comma 1. So Q0 and 1. This one you have to take here, and do not take this A, comma lambda Q0 on 1. Q0 on 1. That is equal to. So the answer of this transition delta Q0 on 1 goes to Q1 state from the given diagram or the table, and output of Q0 comma 1 is equal to capital B. And so this is the transition, and the next is the output we have to find out. So here and it is written, but you can write on the next line also, on the next line, but for the due to the space limitations, I have written in the single line. So you can write on the next line also. So lambda dash Q0 comma A, that is equal to A, right? Because and this here for one state you will get the same value of output because this is the single state. Now Q0 A is the same in single state in the resultant Moore machine. So that's why output associated with the same state is the sorry, single one, right? Now take delta dash Q0 comma B, the state number 2 on 0, and delta dash Q0 comma B on input 1, on input 1. So values are find out here, Q0 comma A and Q1 comma B, and accordingly their output values are also find out here. And finally the Q1 comma A. So these are the 4 transitions on 2 states. This is the state 1 and this is the state number 2. Q0 comma B is the state number 2, the input 0 and input 1. So these are the 2 values we got here, and same way we have got the output for the state Q0 comma B, that is nothing but B. The same way, take the third state is nothing but your Q1 comma A, and for this Q1 comma A, for the third state Q1 comma A, we have find out the transition for this is the third state transition on 0 as well as on 1 input symbol. So we have got here Q1B and we have got here Q0B. This is the next transitions, and output for the state is A. Q1A is the one state, and output associated with this Q1A state is nothing but equal to capital A. And the only fourth state is remaining. Fourth state is nothing but Q1 comma B and on 0 and 1 and 0 and 1. That's why they are written here very separately. So these are the 4 transitions for two states, and these are the remaining 4 transitions for this third state, and this is the fourth state. This is the third state and this is the fourth state, Q1B, Q1B on 0 input, on 1 input. So Q1B, so you have to always here Q1 0, Q1 1. So do not get confused. Q1. So you have to take the input. You have to take the input while finding out the transitions and not the output here. So this value you have to take here. This value you are going to take here. And the Q1 as it is Q1, Q1, Q1. So, right. So delta Q1 0, delta Q1 1, delta Q1 0, delta Q1 1. This may be repeated one, and you are getting Q1, Q0, Q1, Q0, and lambda Q1 0, lambda Q1 1, lambda Q1 0, lambda Q1 1, B, 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 B in both the cases because it is given in the transition table. And finally Q1B, that is the fourth step, and the output associated is capital B, right? So from this we can write the transition table for the resultant Moore machine. So in this way, transition table for the Moore machine, it is written as, say this, Q0 comma A first state, Q0 comma B second state, Q1 comma A and Q1 comma B. These are the resultant state in the Moore machine, and their transitions on 0 input and 1 input, 0 input and 1 input, on 0 on 1 input, and this is their output associated with this state Q0 comma A, output is A, Q0 comma B, output is capital B, Q1 comma A, output is A, and Q1 comma B, output is capital B, right? So from this we can have the transition diagram of equivalent Moore machine. It is drawn like this. Right, so see here Q0 comma A in the square bracket slash A. This is this first thing, first entity. Then Q0 comma B, output is B. Q0 comma B slash B. This is the second one. Then Q1 comma A, output is A. Q1 comma A, output is slash output is A. That is the third. And Q1 comma B, the fourth state, output is B. This is the fourth state, right? And their transition. So Q0 comma A on 0 goes to Q0 comma A. That is the self loop. This one. And on 1 goes to Q1 comma B. On 1 goes to Q1 comma B. This is the transition, right? Q0 comma B on 0, Q0 A. Q0 comma B on 0 goes to this one. This is the transition here. And on 1 goes to Q1 comma B. On 1 goes to here. This is the transition on 1. So in the same way, we have to draw all the resultant transition, and this is the correct conversion from Mealy machine to the resultant Moore machine. Getting this point, you have to draw this diagram very neatly and cleanly, right? Let us go to the next slide. Convert the following Mealy machine into equivalent Moore machine. Now see here, the Mealy machine is given Q0, Q1, Q2. So three states are there, Q0, Q1, Q2. The input symbol. So from the diagram, it is clear that there are input symbol, two input symbols, 0 and 1, and output symbols are there, Y and N. So our output symbols are Y and N. From the diagram, we can conclude that. So draw the transition table for the given Mealy machine as input 0, input 1, and the output is N or Y. So Q0, so there are three states. How many states are there? There are three states, Q0, Q1, Q2, and outputs are N, Y, N, Q0, Q1, Q2. And the state transitions are given here in the written in the transition table. So find out Q dash first, finite set of states where each state is a pair obtained from Q into capital delta is nothing but your state into output, and this is nothing but Q dash is equal to Q0N. How many states are there? There are three states. And how many output symbols are there? There are two output symbols, that is nothing but your Y and N. So how many resultant new states? So 3 into 2 equal to 6. So this particular problem consists of 6 new states in the resultant Moore machine, that is Q0N, this is the first state, Q0Y, it is the second state, Q1N is the third state, Q1Y is the fourth state, Q2N is the fifth, and Q2Y is the sixth state in the resultant Moore machine. Okay. Now what we have to find out here? We have to find out their delta transitions on input 0, 1 for this newly 6 state. So and these transitions find out with the help of this particular equation, delta dash equal to this particular equation and lambda dash equal to the given equation. So let us start finding this. So how many transitions will be there? So there are 6 into 2. There must be 12 transitions. Means we have to find out the 12 different values here. Getting this point or not? Because how many states are new states? 6 states. And how many output symbols? Output symbols are 0, 1. Right. So how many possible transitions are there? There are 12 possible transitions. So we can have Q0N, the state number 1 on 0, and Q0N state number 1 on 1 input. And the value, you know that how to find out the value. So Q0 on 0 delta and Q0 on 1 delta, that we have to find out, that is nothing but Q1, Q2, and lambda Q00, it is N value, lambda Q1, Q01 is the N value. There's 2 transitions for this state number 1 on 0 and 1 input, and the lambda dash Q0N, the value is N as per the give in the transition table, right? Now the next state is your Q0Y. On this is the state number 1. Now this is the state number 2. Q0Y on 0 input and 1 input. So Q0 on 0, Q0 on 1. So Q0 on 0, Q0 on 1. Delta transition Q0 on 0 lambda, Q0 on 1, that is the lambda. So Q0 on 0 is nothing but your Q1. Q0 on 1 is nothing but your Q2. And Q00 lambda means output is N. Q0 on 1 lambda is output is equal to N. right? So this is the third and this is the fourth transitions. Getting this point? And output lambda dash for Q0Y state is Y, because you are taking this Y value here and this N value here. So this is the second state and this is the first state. Okay, so next transitions are for the third state Q1N, Q1N on 0 and Q1N on 1. So this is the third state. So state number 3 on 0 input and 1 input. So I can have delta Q1 0, delta Q1 1. So this delta Q1 0 is nothing but Q1, delta Q1 1, delta on Q1 1 is nothing but Q2, and lambda Q1 0 is the value Y, and lambda Q1 on 1 is value is equal to N. Getting this point? So, and finally, the lambda dash is equal to Q1 on 1, Q1 on 1 is equal to N, capital N itself, right? Now the fourth state is the Q1Y and the Q1Y on 0 and 1. So you are this is your fourth state on 0 input and 1 input, 0 input and 1 input, right? So on Q1 on 0, Q1 on 1, Q1 on 0 goes to Q1, Q delta Q1 on 1 goes to Q2. Getting this point? And lambda Q1 0, lambda Q1 1 is the value Y, and this is the value N here. So from the table we have written here, and lambda dash, so this is the third state Q1Y, the value is output is Y always. For this state it is the N always. Getting this point? So these are the 4 plus 4, 8 transitions are there. So still 4 transitions are remaining. That is nothing but the next state, 2 states, that is delta Q2N on 0 and delta Q2N on 1. So this is the state number, 5 Q2N on input 0 and on input 1. Get this point? On input 0, on input 1, so delta Q2, delta Q2 0, delta Q2 1. So Q2 0 answer is your Q2. Delta, that is transition of Q2 on input 1, the answer is Q2 here. So this is the case. Lambda Q2 0 is nothing but your N. Lambda Q2 1 is nothing but your Y. Get me this point? So, and finally, the lambda dash is nothing but your Q2N, Q2N for the next state, that is nothing but your fifth state, and the output is N for this particular state. And these are the next 2 transitions, and the remaining only one state is remaining, and that state is nothing but Q2Y on 0 and Q2Y on 1. See here, Q2Y, this is nothing but your state number 6 on 0 input and 1 input. So Q2 0, Q2 1. So answer for Q2 0 is Q1, Q2 1 is on Q2, and lambda Q2 0 and lambda Q2 1s are N and Y value. So these are the 11th and 12th transitions. Lambda dash, the output function, output associated with the Q2Y, this is nothing but the sixth number state is nothing but Y. So how many states are there? Number 1, number 2, number 3, number 4, number 5, number 6. These are number of 6 number of states, and for each states we have find out the transitions on input 0 and 1. So total number of transitions, if you count it, so it comes out to be 12 number of transitions. We have find it out just now, right? So this is the way. So while solving this example, we have to write it correctly. Do not get confused. Do not get okay. So write it correctly as per the given transition table and the transition diagram. There is no difficult. There is no, one can say, no critical part involved in solving this problem. So write down the transition table for the Moore machine. So see here, 0, 1. How many states are there? 6 states. So Q0N, the state number 1, Q0Y, Q1N, Q1Y, Q2N, and Q2Y. These are the states and their transitions on input 0 and on input 1. And output with the state Q0N is N, Q0Y is Y, Q0N is N, Q1Y is Y, Q2N is N, and Q2Y is Y itself. And these are the total number of transitions, right? 1, 2, 3, 4, 5, 6, and these 6 total number of transitions are 12. So from this transition table, the transition diagram is drawn like this. So transition diagram of equivalent Moore machine can be drawn as Q0N, Q1N, right? So Q0N, so Q0N, so right here N, then Q1N, Q1N, the output is N. So Q1Y slash Y, then Q1N slash N, then Q2Y slash Y, and Q0Y slash Y. All these are the states. and their corresponding transitions are drawn in the particular diagram, and this is your resultant Moore machine. Getting this point? So these are the examples how we are converting the Mealy machine to the Moore machine. Let us go to the next slide. Okay. So see here, there are two questions are given here for to solve. The first diagram is given Mealy machine. You have to convert into the resultant Moore machine, and the second example or the second question is also given. The states are given Q0, Q1, Q2, Q3. There are transitions with the input as A and B. So in the first case, your output function is also 0, comma 1, and input also 0, comma 1. But in this case, you have the input, that is lambda sigma equal to A, comma B. But whereas the capital delta is equal to 0, comma 1, because this is your input symbol and this is the output symbol, right? So output symbol is 0, comma 1, and inputs are now A and B. So accordingly, you have to write down the Q dash and then find out the delta dash and then the lambda dash. So here both is 0. This input is 0, comma 1, and output is also 0, 1. So lambda capital delta is 0, comma 1, and sigma is also 0, comma 1. So accordingly, Q dash, then delta dash, and then lambda dash, we have to find it out. Okay. So these are the questions for the homework, right? Okay, so we have learned in this particular session conversion of Mealy machine to the Moore machine. The course outcome attainment of the session to construct a finite state machine to solve the problems in computing. Always refer the standard reference book. Okay, so thank you. So let us stop here for the today's session.